In the early 1940s, as the flames of World War II consumed Europe and Asia, the United States Army Air Forces realized that defeating a deeply entrenched, island-bound empire like Japan would require a weapon of unprecedented range, speed, and payload capacity. The answer to this existential strategic challenge was the Boeing B-29 Superfortress. It was not merely an evolutionary upgrade to existing bombers, like the B-17 Flying Biofortress or the B-2 for Liberator. It was a revolutionary leap in aviation technology, a multi-billion-dollar gamble that ultimately redefined the nature of strategic bombardment and brought about the end of the war in the Pacific. To understand how the B-29 became the ultimate strategic weapon against Tokyo, one must examine its complex development, its revolutionary engineering, the dramatic tactical shifts orchestrated by American commanders, and the devastating campaign that permanently altered the course of military history. The genesis of the Superfortress lay in a 1939 requirement issued by the United States Army Air Corps for a super bomber capable of carrying a massive bomb load across thousands of miles. The primary anxiety driving this request was the possibility that Great Britain might fall to Nazi Germany, leaving the United States with no forward bases in Europe. American planners needed an aircraft that could take off from Newfoundland, bomb targets in continental Europe, and return without refueling. While the European theater stabilized enough to avoid this extreme scenario, the vast distances of the Pacific Ocean soon presented an even more daunting geographical challenge. Japan's industrial heartland was protected by thousands of miles of ocean and heavily fortified island chains. Standard bombers simply lacked the reach to strike the Japanese mainland from any secure American base. Boeing stepped forward with the XB-29 design, a massive four-engine aircraft that promised to push the boundaries of aerodynamics and engineering farther than any project in history, ultimately costing more to develop than the Manhattan Project itself. Engineering the B-29 required solving problems that had never been encountered in mass-production aircraft. Chief among these was human endurance at high altitudes. Previous bombers forced crews to wear heavy, heated flight suits and oxygen masks to survive the sub-zero temperatures and thin air above 20,000 feet. This caused severe fatigue and degraded operational efficiency during long missions. Boeing's solution was a fully pressurized cabin. The fuselage was divided into 3 pressurized compartments: the nose section for the pilots, bombardier, and navigator, a mid-section for the gunners, and a tail compartment for the rear gunner. These sections were connected by a long pressurized crawl tube running over the unpressurized bomb bays, allowing crew members to move back and forth in relative comfort wearing standard uniforms. This single innovation allowed crews to arrive over their targets fresh and alert, even after 10-hour flights to power this airborne leviathan. Boeing utilized 4 massive Wright R-3350 duplex Cyclone radial engines, each equipped with twin turbojets. These engines generated a staggering 2,200 horsepower each, giving the B-29 a top speed of over 350 miles per hour and an operational ceiling of over 30,000 feet. At this altitude, the Superfortress was virtually immune to most Japanese fighter aircraft and anti-aircraft artillery, which struggled to climb high enough or track fast enough to intercept it. However, this cutting-edge power plant was also the aircraft's greatest weakness during its early deployment. The R-3350 engines were notoriously prone to overheating, often catching fire in mid-air, because the cooling fins were insufficient for the immense heat generated by the tightly cowled radials. Pilots joked that they spent more time watching their engine temperature gauges than looking for enemy fighters. Despite these mechanical vulnerabilities, the sheer speed and altitude capabilities of the B-29 made it an apex predator of the skies. Another technological marvel of the Superfortress was its defensive armament system. Instead of traditional manned gun turrets, which created immense aerodynamic drag and required gunners to manually track targets through heavy wind resistance, the B-29 featured the General Electric Central Fire Control System. This system utilized for remote-controlled turrets armed with twin .50 caliber machine guns, along with a combination of machine guns and a 20mm cannon in the tail. Gunners sat in pressurized bubbles with panoramic views, using electronic sights equipped with analog computers to track enemy fighters. The computer automatically calculated the lead angle, gravity drop, and windage, allowing a single gunner to control multiple turrets simultaneously, or hand off a target to another gunner as it moved across the sky. This computerized defense grid turned the B-29 into a flying fortress in the truest sense, capable of throwing up a wall of lead that decimated intercepting fighters. The initial operational deployment of the B-29, designated Operation Matterhorn, exposed the limits of traditional American bombing philosophy when applied to the unique conditions of Asia. Operating under the XX Bomber Command, B-29s were stationed in India and staged through forward bases in Chengdu, China. The logistical nightmare of this arrangement was staggering. Every drop of fuel, every bomb, and every spare part had to be flown over the hump, the treacherous Himalayan mountain range by the transport aircraft and the B-29s themselves before a single mission could be launched against Japan. Furthermore, flying at high altitudes over Japan revealed the meteorological phenomenon previously unknown to Western aviation, the jet stream. High-velocity winds reaching speeds of nearly 200 miles per hour blew American bombers off course and scattered their high-explosive payloads miles away from their intended targets. Precision daylight bombing from high altitudes, the cornerstone of American air doctrine in Europe, was proving to be a costly and inefficient failure in the Pacific. The strategic equation changed dramatically in late 1944 with the capture of the Mariana Island Saipan, Tinian, and Guam. These islands provided the United States with ideal, secure bases within 1,500 miles of Tokyo, eliminating the logistical bottleneck of China. Massive construction efforts by the Navy Seabees transformed these tropical islands into the largest airports in the world, featuring miles of asphalt runways capable of handling hundreds of superfortresses simultaneously. Control of the bombing campaign shifted to the 21 Bomber Command, and in January 1945, a new commander arrived who would fundamentally alter the way the B-29 was utilized. Major General Curtis LeMay. LeMay was a pragmatic, aggressive tactician who realized that the B-29's current methodology was wasting its immense potential. He analyzed the failure of the precision bombing raids and recognized two critical factors about the target nation. First, Japanese industry was highly decentralized, relying on thousands of small family-owned shadow factories and workshops scattered throughout residential neighborhoods to feed components to major assembly plants. Striking a single large factory did not stop production if the feeder network remained intact. Second, Japanese cities were incredibly vulnerable to fire, constructed primarily of wood, plaster, and paper. LeMay decided to abandon precision daylight bombing from high altitudes. Instead, he proposed a radical, high-risk strategy: low-altitude, nighttime incendiary attacks. This tactical pivot stripped the B-29 of its traditional defenses to maximize its offensive efficiency. LeMay ordered the removal of nearly all defensive guns and ammunition from the bombers, leaving only the tail guns. This reduced the weight of the aircraft by thousands of pounds, allowing them to carry significantly more fuel and double their bomb load. Furthermore, by flying at night between 5,000 and 9,000 feet, the B-29s bypassed the turbulent jet stream and avoided the bulk of Japan's heavy anti-aircraft batteries, which were calibrated for high-altitude targets. Operating at night also neutralized Japan's visual night fighters, which lacked advanced airborne radar systems to intercept the incoming bombers. The weapon of choice for this new campaign was not the standard high-explosive bomb, but the M69 incendiary bomblet, a canister filled with napalm-like jellied gasoline designed to scatter upon impact and ignite uncontrollable infernos. The ultimate test of this new doctrine occurred on the night of March 9th to 10th, 1945, under the codename Operation Meetinghouse. Over 300 B-29 Superfortresses took off from the Marianas and converged on the densely populated working-class districts of eastern Tokyo, arriving in waves. The lead bombers used radar to identify the target zones and dropped incendiaries to create a massive glowing X across the city. The following waves then systematically filled in the cross, unleashing over 1,600 tons of incendiary clusters into the heart of the metropolis. The result was a firestorm of apocalyptic proportions. The intense heat created superheated thermal updrafts that acted like chimneys, sucking in oxygen from the surrounding areas and creating ground-level winds of hurricane force that spread the flames with terrifying speed. The devastation wrought by Operation Meetinghouse remains the most destructive single air raid in human history, surpassing the casualties of the subsequent atomic bombings. Approximately 16 square miles of Tokyo were completely incinerated, reduced to a wasteland of ash and twisted metal. Over 1 million people were left homeless, and an estimated 100,000 civilians perished in the conflagration, asphyxiated by the lack of oxygen or consumed by the intense heat that boiled canals and melted asphalt. The industrial output of the Japanese capital was instantly paralyzed, as the complex web of home workshops and major manufacturing plants vanished overnight. From a purely military standpoint, LeMay's radical tactical shift had proven that the B-29, when utilized as an area-dial incendiary platform rather than a high-altitude precision instrument, possessed the power to dismantle an entire nation's industrial capacity from the air. Following the horrific success of the Tokyo raid, The 21st Bomber Command systematically expanded the incendiary campaign to Japan's other major urban centers, including Nagoya, Osaka, Kobe, and Yokohama. The Superfortress had become an unstoppable engine of total war. The Japanese military, depleted of aviation fuel, trained pilots, and modern aircraft, could offer only token resistance. American air crews, who had once feared the fiery engine failures of the early R-3350 models, now flew over Japanese cities with near total impunity, encountering empty skies and disorganized flak. The B-29 had successfully severed the supply chains of the empire, isolating the home islands and breaking the back of the domestic war economy long before any Allied soldier set foot on a Japanese beach beyond conventional and incendiary bombing. The B-29 proved its versatility through Operation Starvation, a highly effective aerial mining campaign conducted in the spring and summer of 1945. Dropped thousands of advanced acoustic and magnetic naval mines into Japan's vital shipping lanes, harbors, and internal waterways, such as the Shimonoseki Strait. Because Japan was an island nation completely dependent on maritime imports for food, oil, and raw materials, this aerial blockade was catastrophic. Shipping tonnage dropped by over 90%, grinding remaining industrial production to a halt and bringing the civilian population to the brink of mass starvation. This campaign demonstrated that the B-29 was not just a blunt instrument of destruction, but a sophisticated strategic tool capable of choking a nation's logistical lifeblood from above. The culmination of the BT's role as the ultimate strategic weapon occurred in August 1945, when modified versions of the aircraft, known as the Silver Plate configuration, carried out the ultimate extension of strategic bombardment. These specialized superfortresses were stripped of all armor and most weaponry to accommodate the immense weight of the world's first atomic weapons. On August 6, the B-29, named Enola Gay, piloted by Colonel Paul Tibbets, dropped the Little Boy uranium bomb on Hiroshima. 3 days later, on August 9, another B-29, named Boxcar, dropped the Fat Man plutonium bomb on Nagasaki. The unimaginable destructive power of these two single missions, executed by solitary aircraft flying unescorted through the Japanese morning sky, forced the Japanese leadership to accept the reality of absolute defeat. The Superfortress had delivered the final, undeniable blow that ended World War II without the necessity of a bloody, costly amphibious invasion of the Japanese mainland. In retrospect, the Boeing B-29 Superfortress represents a watershed moment in the history of warfare. It was the physical manifestation of the doctrine of total strategic air power, proving that an adversary could be defeated by the systematic destruction of its industrial base and civilian morale from the air. The aircraft itself was a triumph of American industrial might and technological innovation, overcoming severe mechanical defects and geographical hurdles to achieve its objectives. By bridging the gap between conventional aerial warfare and the atomic age, the B-29 did not just win the war against Japan. It laid the structural, technological, and doctrinal foundations for the modern United States Air Force and the era of global strategic deterrence that defined the latter half of the 20th century.